There's the tricky part to number 4 is actually realizing what it's asking you for. So we have a race car starting from rest, accelerates from 0 to 60 miles per hour in 3.5 seconds. If the acceleration is constant, find the distance that the car travels in each of the first 2 seconds. So what it's asking for is if the total distance the car traveled, this is where we started at 0, and it went this way, the total displacement in 3.5 seconds. It wants to know after 1 second how far this distance is here, and during that second, so at 2 seconds right here, how far this distance is there. So we'd have x1 and x2, and all the way down here would be our total displacement for the motion, or we could say even more accurately x final. Alright, so if we go through the problem, we know we start from rest. So our initial velocity is 0. I'm going to put it in meters per second because that always helps us out. Our v final at the end of the motion is 60 miles per hour. I'm going to assume that you know how to convert that by now. So we have 27.1 meters per second. And we know the whole motion took place in 3.5 seconds. And it's asking for delta x, but we first need to find, since we have no information on it, the acceleration. So in meters per second squared. So if we use equation number 1 and solve that for acceleration, we get Vf minus V naught divided by the time, all that information we have. So 27.1 meters per second minus 0 meters per second, all divided by 3.5 seconds. So that gives us an acceleration of 7.7. Try that again. 7.75 meters per second squared. Alright, so that's our acceleration. So the first, we're going to find how fast it's going here, so we can solve for our displacement. So we want to find our Vf at 1 second. So we go to Vf equals V naught plus AT. We have all that information. Our initial velocity from 0 to 1 second is 0 meters per second, plus our acceleration, 7.75. Do that again. So 5 meters per second squared times our 1 second interval. So we find that Vf after 1 second is 7.75 meters per second. Okay, and that makes sense because we only accelerated for 1 second. And, that's what the acceleration is telling us. We increase our velocity by 7.75 meters per second every second we go. So that's the final velocity for that first second. I'm going to pause the video and start again.